All right, now we want to talk about radical equations. These are equations that, guess what? They've got radicals in them. More specifically, they're equations where your variable is stuck inside of a radical. Remember how we had rational equations and we had variables in those denominators? Your job in that section was to clear the fractions out, and you're able to get the variables in a place where you could actually solve for them, right? And the same thing's going to happen here with radical equations. Your job is to get rid of the radicals, and then everything is pretty happy. Now, in order for us to solve radical equations, we need to understand the power property. Okay, and here's what the power property says. It says that all solutions to the equation A equals B can be found among solutions to A to the n equals B to the n, where n is a natural number. Basically, it says you can raise both sides of the equation to the same power to get something that's mostly equivalent, as long as you're raising it to an appropriate power. A natural number is what we call counting numbers, 1, 2, 3, 4, and so on. Of course, raising it to the first power doesn't do anything, but maybe you want to square both sides. If you square both sides, that might allow you to cancel what? Square roots. You could raise both sides to the third power if you were trying to cancel what?
Cube roots.
Cube roots. Okay. Now we have a few steps for working radical equations. The first step is to isolate a radical. Okay, what does isolate mean? Isolate means get it by itself. So your job when you see one of these radical equations is, all right, get the radical by itself first. Okay? Do you understand what that means? This is number one, get it by itself. Because when you do that, you're going to apply the power property. That means you're going to raise both sides of the equation to an appropriate power that's going to cancel out with your radical. Like we said before, if you have a cube root, what power will you use? The third power. If it's a square root, you'll use what? The second power. Okay. So isolate a radical, apply the power property. Step 3, this is kind of a weird one. You repeat steps 1 and 2 if a radical remains. Some of the equations that we come across will have multiple radicals. So you isolate one, apply the power property, and then you go and you isolate the other one. So once you've done that, you solve the resulting equation. And as we saw with rational equations, sometimes the result is a linear equation, sometimes the result is a what other type of equation?
Oh.
If it's not linear, then it's more than likely what? Quadratic, right? Where we're going to have to factor. Okay. This last step is super important for us. We have to check into the original equation. Check into the original equation, because just like with rational equations, we might have something that's extraneous. There's no guarantee, but there's always the possibility. For example, if I just start with this guy right here, if I say I have the square root of x plus 7 is equal to 20. Again, to make sure that you write things clearly and concisely. So you see that the square root is just on what? Square root is just applied onto the x, not the plus 7. So if I follow the steps that I've given to you, what's the first thing that you're going to do?
Square root of x minus 7.
And how do I do that?
Subtract 7 on both sides.
Doesn't this make you happy to subtract 7 on both sides? A little bit. Incrementally happy?
I'm not too complacent yet.
All right, so if I subtract 7, that means I have the square root of x is equal to what? Is equal to 13. I've got my radical by itself. Step 2 says apply the power property. Well, that means I need to raise both sides of the equation to the same power, but I need to have a power that's going to cancel out, be the inverse operation for the square root. What's that power?
Second.
The second power.
That means x.
Because what again?
I want to be able to undo the square root. So to undo a square root, you would square it. And check this out in your calculator. A lot of things in your calculator deal with inverse operations. Look at this real quick. It may be hard to see, but you've got your squaring button here. The inverse is above it, which is the square root. You see that here with the log, with the sine, cosine, tangent functions. These are guys that you may not see for a while yet. But a lot of times when you do second and these buttons, you're talking about doing the inverse operation. Okay, so there's that connection there. In case you happen to forget that, you see, oh yeah, those guys are connected. It makes sense for them to be the same button right there.
I thought that button was just x to the first.
Oh, well, no. So when I square the square root of x, what do I get?
X.
I get x. On the other side, though, what do you get?
169.
Before you box this, though, you have to check. And you have to check into your original equation. Sometimes you come up with answers that aren't true. Remember with rational equations, we had to check against our restricted values? Because sometimes there's a restriction that was built into that with us working it.
Is that when you
But
use the
there's
zero
plus
factor?
seven is 20.
does equal 20.
No, we just have to make sure that this checks out, because this square root symbol, we call this the principal square root, so it only returns the positive square root, right? So when I check this guy,
It's true.
is the square root of 169 plus 7 equal to 20? That's the question. Well, the square root of 169 is, so 13 plus 7 equals 20. Do y'all agree? So we check that, we know this is right, so I can finally box my answer. The answer is x equals 169. Questions about that?